Hello there, everyone. I'm making this video to go over how to fill out the first table in CrytsalMaker Assignment 3. So what we're going to be doing is looking at several silica polymorphs and taking some measurements using CrytsalMaker. So the files you're going to want to look at are going to be given to you specifically so that we all know which files exactly we're talking about, which structures we're talking about, that kind of thing. So under the framework silicates, that's the first section here. We scroll down, 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 and here we are at table 1. So again, we are looking at the SiO2 polymorphs, and the ones we want you to look at are listed here, but notice that they are available for download at this hyperlink. So you click that, it'll launch a new window, and you can download the structures there. Okay, so when we are looking at each of these polymorphs, we're going to take a look at the tetrahedra that are within them. We're going to calculate the average bond lengths and the average bond angles for between silicon and oxygen. And so I just want to run through that. So I have some structures loaded already in CrytsalMaker. So what I have here is alpha quartz, and you'll notice that is the first one here. So we're doing a couple questions here for you all. Okay, so when we're looking at the average bond length, what do we want to do? In CrytsalMaker, let me move my camera so that you can see the sidebar. We see we have just silicon and oxygen. That's all we're dealing with here. SiO2 polymorphs, all we have silicon and oxygen. Okay, but we can't see the bonds, so I'm going to change to ball and stick. Much better. I can see the bonds now. And we want to pick one of these many, many tetrahedra that will allow us to calculate a good bond angle and length. And so what I'm going to do is I'm going to zoom in. I'm going to make sure I'm looking at just one of these tetrahedra. And you kind of, you want to make sure that you have a structure that has all of its bonds. On the edges of the structure, you can see how like these silicons on the outside are pointing off into nothing. You don't want to measure one of those. There should be 4 bonds coming off of one silicon, and that's what we're measuring. Okay, so let's try to get this one here. This has 4 bonds. I can count them 1, 2, 3, and 4. And then we're going to use the toolbar here. And if you forget where to get this menu up here in the top left, you can click the toolbar on and off. And down in the left-hand column, there is this icon that 2 bonds with arrows pointing between them. We're going to click that. And now you can see, well, it said bond measuring tool down there at the bottom, but now it wants us to click on an atom. So I'm going to take that oxygen and I'm going to go to this center silicon atom. And I can see that I'm going to click again, and now I can move my mouse without it snapping to new atoms. I just did that by clicking once on the oxygen, once on the silicon. So now I can see that we have a bond distance of 1.605 angstroms. And you all can do this by pencil and paper if you like, but I prefer Excel if I'm going to like tabulate data, that kind of thing. So I will bring this on to this side of the screen. Okay, so for my tetrahedral site, I'm going to be measuring 1, 2, 3, 4 bonds. You can see them right here. 1, 2, 3, and 4 makes a tetrahedron. Okay, so the first one that I measured was 1.605 angstroms. The next one, we're just going to go back into CrytsalMaker. Still have our bond measuring tool selected. Click on the next oxygen, and then to the center silicon, 1.613 angstroms. 1.613. We'll do that again. Silicon out to the oxygen, another 1.613. And the last one out here, oxygen to silicon, 1.605. Okay, but you'll notice if we go back to our assignment that we're asking for the average bond length. So again, you can do this by pencil and paper if you like, but I like to do it in Excel. Take the average. So what I did here is I just typed the equal sign. And you can see I started typing average and this pops up, and then I can hit tab or I can click on that, but I'm going to hit tab. Now Excel wants me to put in some numbers that I'd like to average, and I'd like to average these four. I just click and drag, hit enter. My average is 1.609, so that's what I'm gonna input in here. Perfect. Okay. Now what we want to do is get the average bond angle between oxygen, silicon to another oxygen atom. And so this part can get a little wonky if we're not careful. Again, in the tool menu, left-hand column, right below the bond measuring tool, there's this angle that has spheres on it. We're going to click that, and now we want to measure bond angles. So we'll use this same silicon tetrahedron. And like you can see, I can click this oxygen, but that's the tetrahedron behind the one I'm interested in. So be careful with that. And also make sure you're starting at an oxygen. We're going oxygen to silicon to oxygen again. If we were to do like this oxygen to this other oxygen, this is in the same tetrahedra, and then down to the silicon, that's not the angle I'm interested in. Okay. No, I've messed it up. Okay. Click again. I've clicked the oxygen that I'm interested in, down to the silicon, and then to the other oxygen. Now I click, and you see at the bottom it says, click this atom to freeze bond angle. You can keep going and drag it onto new atoms, but that freaks it out. So we're going to click again, and now it's frozen. I can move my mouse around. You can see this angle here, 108.79. So I'm going to go in here. I've already done this math. So 108.79. Do the next angle. We'll go down here to the middle, up to the first one, 108.87. You can see it's freaking out there because I didn't click again. Make sure you click again. Okay. Now we'll go here, down there, to this corner, 109.27. I didn't click again. You see if I was to move my mouse around, it'd be freaking out. So I'm going to click the atom again before you move on. So we got another 109.27, or our first 109.27. And lastly, we'll take the angle at the bottom here. Oxygen, silicon, oxygen, click again, frozen. Okay, 108.79. We just do the same deal where we take the average of these four. 108.93 is my average, so I'll go back to my table. What was it? 108.93. Perfect. Okay, so that was just pretty much demonstration of how to attack that the first two columns of that table. The coordination number you all are pretty familiar with. And then for the temperature and pressure ranges, you will use this this phase diagram. This is explained to you in the instructions above, but make sure temperature, pressure, we're using this phase diagram. Something I do want to bring up though, before I go, is that there's one structure, cosite, which I do have pulled up. And if you're looking at the sidebar, you'll notice something right away. There are two tetrahedrocytes. I'll pull up the other structure again just so we can compare. Why don't we look them both at the same time? So compare the two sidebars here. In alpha quartz, which we were just measuring, you can see there's only one silica tetrahedron. On this coesite, there's two. So you'll need to do 2 rounds of measurements for the angles, 2 rounds of measurements for the bonds, and then average those. Okay. I hope you enjoyed this, and we'll see you in the next video.